Trigonometry, Chapter 5, Trigonometric Identities, Section 4, More Identities, Video 12, using half-angle identities, Part 2. This series is based on content from Pearson's Trigonometry 12th edition by Lial, Hornsby, Schneider, and Daniels. Excuse me. In the previous video, we evaluated trig functions using half-angle identities. Here we see all the half-angle identities. Just a reminder, anytime there's a plus minus, that decision is made based on the trig function being evaluated at x over 2 and the quadrant of x over 2. In this video, we evaluate half-angle expressions when a trig function's value is given. Sorry, folks. All right, for example, if cosine of s equals 2/3 with 3 pi over 2 less than s less than 2 pi, find sine of s over 2, cosine of s over 2, and tangent of s over 2. Normally, when we're given an interval about the angle, or in this case, the arc, it's so that we can determine a quadrant for that arc. But since we're evaluating trig functions at s over 2 and not s, we'll have to transform this inequality into an inequality about s over 2, not an inequality about s. That will be easy to achieve. To achieve that, we simply have to take the given inequality and divide all three parts by 2. 3 pi over 2 divided by 2 is 3 pi over 4. S divided by 2 is s over 2. And 2 pi divided by 2 is just pi. Since 3 pi over 4 is less than s over 2 is less than pi, this places s over 2 in quadrant 2. This means sine of s over 2 is positive, while cosine of s over 2 and tangent s over 2 are negative. Let's start with sine of s over 2. Here's our half-angle formula, the square root of 1 minus cosine of s all over 2. Notice we don't have the plus minus because we've already determined that in quadrant 2, sine is positive. Now we simply substitute the value of cosine of s, 2/3, into the identity for cosine of s and simplify. Cosine of s becomes 2/3. 1 minus 2/3 is 1/3. To do 1/3 divided by 2, we could do 1/3 times 1/2, which is 1/6. And now we can split this into two square roots, square root of 1 over the square root of 6. However, the square root of 1 is just 1, so we get 1 over the square root of 6. If we rationalize the denominator by multiplying both sides by the square root of 6, the top becomes the square root of 6, but the bottom becomes just 6. So sine of s over 2 equals the square root of 6 over 6. Similarly, for cosine of s over 2, we'll use the identity negative square root of 1 plus cosine of s over 2. Negative is chosen because we're in quadrant 2, and cosine is negative in quadrant 2. Again, we'll substitute the value of 2/3 for cosine of s in the identity, giving us negative square root of 1 plus 2/3 all over 2. 1 plus 2/3 is 5/3. 5/3 divided by 2 is the same as 5/3 times 1/2, which is 5/6. And we can split this into two square roots. Don't lose the negative in front. We have negative square root of 5 over the square root of 6. And if we rationalize the denominator by multiplying both sides by the square root of 6, the top will become the square root of 30. The bottom will become just 6. Therefore, cosine of s over 2 equals negative square root of 30 over 6. Quick comment about this fraction. It looks like it should reduce. It won't. 30 and 60 have common factors, but you can never mix numbers inside a square root with numbers outside a square root. So the only thing we could try to do is simplify the square root of 30 and then try to reduce. But if you check, the square root of 30 can simplify it no further. Now let's find tangent. Now we have a tangent and half-angle identity. We have 3 of them, in fact. And we could use that to find tangent of s over 2. But we can use a quotient identity instead, because we know the value of sine, we know the value of cosine. And if we put them on top of each other, that'll give us the value of tangent. Sine was square root of 6 over 6. Cosine was negative square root of 30 over 6. If we were to multiply both sides of this large fraction by 6. Then it would cancel the 6's and leave us with negative square root of 6 over the square root of 30. You might have noticed that I subtly moved the negative from the denominator to the front of the fraction. I just think it looks better there. Now, normally we would rationalize the denominator here, but look a little more closely at the square roots. Because both of the numbers are under square roots, we can treat this like we're reducing fractions. To explicitly show you, notice that 6 is a factor of 30, so we could rewrite the square root of 30 as the square root of 6 times the square root of 5, and then the square root of 6's would cancel, leaving negative 1 over the square root of 5. Of course, we would rationalize the denominator next by multiplying both sides by the square root of 5, giving us negative square root of 5 over 5. And now we have all three trig function values of s over 2. Now, had you rationalized before simplifying, remember, we had this. And had you rationalized before simplifying by multiplying both sides by the square root of 30, you would have gotten, let me get the laser pointer up. Come on, laser pointer. You would have gotten negative square root of 180 over 30, which is trickier to simplify. It's not impossible, but you would have to break down the square root of 180, and the fastest breakdown is square root of 36 times the square root of 5. Now you try. Pause the video and try the following. Given cosine of s equals negative 3/7, and pi is less than s is less than 3 pi over 2. Think about what quadrant we're in. Find sine of s over 2, cosine of s over 2, and tangent of s over 2. Pause the video, give it a try. All right, here's your fair warning if you haven't paused the video. Solutions in 3, 2, and 1. If you adjust the inequality for s over 2, you would see that s is in quadrant 2, where sine is positive, everything else is negative. Then sine of s over 2 ends up being square root of 35 over 7. Cosine of s over 2 ends up being negative square root of 14 over 7. And tangent of s ends up being negative square root of 10 over 2.